Hey guys, it's Janek from Elympics, and in this tutorial I'm going to show you how to create a simple, asynchronous, competitive game using the Elympics SDK. This tutorial will consist of two parts. This one, in which we will go over setting up your project and creating the gameplay part of your game, and the second one coming later, in which we will be building your game and integrating it with Telegram and Web3 using packages and samples provided by Elympics. We are going to start by setting up an Elympics account. To do that, we go to console.elympics.ai. If you've already got an account, log in, and if you don't, you can create one by choosing the Sign Up button. Once logged in, we create a new game, give it a name of your choosing, and make it an endless runner with one player per gameplay. In the second step, we add a solo queue with no bots and press Create New Game. With our account and game created, we now have to add the Elympics plugin to Unity. To do that, we go to Window, Package Manager. In the Package Manager window, we click on the plus icon in the upper left corner and choose the Add Package from the Git URL option. In there, we paste the link to the Olympics Git repository. This link can be found in the description of this video or in the installation section of our documentation at docs.elympics.ai. Once the package is installed, we go to Tools, Olympics, Manage Games in Olympics, and log in using our Olympics account. When logged in, we press Synchronize to view the list of our games where we should see our newest game. We press Create First Game Config and copy the game name and game ID from the list above. In the gameplay scene field, we choose the scene we will want to use for implementing the gameplay part of our game. For quick testing during development, we will use the half remote mode, which allows us to run both the player and server instances in Unity. To do that, we start by creating a clone of our project. Click on the Parallel Sync Clones Manager, and in the newly opened window, we choose the option to create a new clone. Once it's there, we open the clone in the new editor. We can recognize the clone instance by the clone suffix in the project name displayed by the Unity window. On the main instance, we press Tools, Olympics, select or create config. In the inspector window, we change the mode to half remote and save the project. If done properly, the mode in the clone instance should change automatically and display the half remote mode as client. To test our game, we have to press play on the main instance first and later on the clone instance, and proceed to test the game on the clone instance. For the tutorial purposes, we are creating an extremely simple project that will consist of one synchronized object, 4 scripts, and a set of UI elements to display the game logic. Once you're ready to create a more complicated game, we invite you to read about Elympics SDK capabilities in our documentation at docs.elympics.ai. For Olympics to work in your game, the gameplay scene needs to contain the Olympics system object. To add it, right-click in the hierarchy window and select Olympics, Olympics System. For an object to be considered a part of synchronized logic, it must contain an Elympics behavior component. Let's create the empty game manager object and add the Elympics behavior to it. In the predictable for section, we need to set the prediction to player for the object to be updated by both the server and the player instance of the game. If the prediction was set to none, only the server would update the object and players would receive information about it with a delay. While Elympics can support any number of synchronized entities, we need to keep in mind that each synchronized value adds to the amount of data that is being sent and received by the game. In the case of bigger projects, it is important to be smart about choosing these values and focus on synchronizing only the important ones that influence the game logic the most. The 4 scripts that we will create for our game will be the game manager, which will update the main game logic, map manager, which will hold synchronized information about the map containing obstacles, player manager, which will manage players' input and hold information about the player, and display manager, which will update our UI and display game's logic. Once created, add them all to the manager object. The UI elements that we will need to include are the following: score, a text object to display player's score, timer, a slider that will be showing how much time we've got left in the game, 5 rows of tiles, a 2-column grid of images that we will use to show which tiles are safe and which have obstacles on them, player, an image that we will be moving around to show whether the player is on the left or right, buttons, 2 invisible buttons spanning the whole screen that we will use to detect players' input, and a game over screen, an object containing an image and 2 text objects that we will activate when the game will have ended. With everything set up, we can start programming in the game's logic. Since we are working with a server authoritative architecture, all input should be sent, received, and then processed. We will be sending input from our player manager script. To do that, we make it implement the iInputHandler interface from the Elympics library. We need to create a private variable from which we will take the value to send it to the server. Let's make it a private int and create a public method for setting its value, which we'll be calling when pressing the buttons on the UI. Implementing the iInputHandler interface should create two methods, onInputForBot and onInputForClient. Those are the methods that send input to the server instance each tick, for the bots and players respectively. Let's leave the body of the onInputForBot empty, since we won't be using it in our project. Inside of the onInputForClient method, we use the write method that is provided by the input serializer and pass into it our current input. After sending the input, we reset it to its neutral value of 0 to not send our singular input twice. If you were creating a game in which player movement is continuous, you wouldn't need to reset it. Elympics input system is explained in detail in the guide input section of the documentation at docs.elympics.ai. The input will be used to move the player between right and left, so let's add a synchronized variable to store information about their current position. Synchronized data is stored in the Elympics variables. You can read about them in detail in the guide state synchronization section of the documentation. We will create a private boolean using the Elympics bool type. Elympics variables need to be initialized before we can access their value. Let's also create a public getter and a public setter for the variable's value. Remember to call setCurrentInput when clicking the buttons set up on our scene. With input being sent from the player manager script, we now have to receive it in the game manager script. The reason why we can read input sent from another script is because both scripts are attached to the same Elympics behavior component on our game manager object. Receiving inputs happens in the main game loop used by the Elympics for synchronized logic. Elympics Update works very similar to Fixed Update in Unity. However, it uses Elympics tick duration instead of fixed delta time for the calculation of the logic step. To access it from a script, our class must inherit from the Elympics MonoBehavior class and implement the iUpdatable interface. To read the input, we use the Elympics behavior.tryGetInput method. In it, we specify which player we want to read the input from. In case of a game with only one player, it will always be the player with the index of 0. We collect the input using the read method of an iInputReader object. In case of sending multiple variables as inputs, it is important to always read them in the exact same order as the one they were sent in. Due to the unstable nature of the internet, it is important to keep the game logic independent of receiving input successfully. That is why, while reading of the input is enclosed in an if statement, processing input will happen outside of it. Let's check if the input we've received is not a neutral input. And if so, let's set the player's position to either left or right. To display player position, let's create a display player method in our display manager script. It will change the anchored X position of our image to either a positive or negative value. We then call it from the game manager after moving the player. Now, let's create logic for our obstacles. The information about which tiles contain obstacles will be stored in a synchronized array of booleans, which will hold the true value in each slot with an obstacle. Olympics arrays are different from the regular Olympics variables in that their values need to be initialized at the beginning of the game and not before it. To do that, we will use the initialize method from the iInitializable interface. To fill in the map as the game progresses, we will need two methods. One to move the rows down, and one to generate the new row. To have a randomized map in a server authoritative game, we must use a predictable random. It works by generating a new system random from a combination of a set seed and a predictable modifier. Each time there is a need for a set of random values. You can read in detail about predictable randomization in the Samples, Random Events and Level Generation section of the documentation. Based on our new random, let's choose one of the three options, where there is an obstacle on the left, on the right, or no obstacle at all. And use them to fill the final row. Let's create the public updateRows method that will call both moveRows and generateNewRow methods. From our game manager, let's call the updateRows method each time the player moves. In our case, to make the game more random, we will pass current tick number in as the predictable modifier for our method. Finally, let's display the changes. In the map manager, let's create a method for getting our map in the form of a list of booleans. In our display manager, we will create a method displaying the obstacles by changing the color of the pile to green if it's safe, or to red if it contains an obstacle. Finally, let's call the display method each time we update the obstacle rows. With our map logic working, we must now check if the player is colliding with any obstacles. In Game Manager, after the rows have been updated, let's check if there is an obstacle on the first row where the player is currently standing. Let's get the obstacle list and check the value of a respective tile. If the player is safe, we will increase the score, which we will keep as an Olympics integer. And if he isn't, we will end the game. The Olympics endgame method can only be called by the server instance, so let's create a method that will check that when called. In Display Manager, let's create methods for displaying the score, and the Game Over screen. After that, let's call those methods from the Game Manager. For a game to not last forever, let's also create the final part of the game's logic, which is the timer. Let's keep its values in an Olympics float variable. We will set its initial value at the beginning of the game in the initialize method. And decrease it each Olympics update by the tick duration. Once the value reaches 0, we will end the game. In our Display Manager, we create a method to display remaining timer value on a slider. And call it in the Game Manager after decreasing the value of the timer. With our gameplay logic, we need to make sure that every reference is properly set up on our scene. When finished, make sure to test the game using the half remote mode to make sure that there are no synchronization issues between the instances. That's it for this tutorial. In the next part, we will look at the process of building your game for online play and integrating it with Telegram and Web3 using the packages and samples provided by Elympics. In the meantime, you can learn more about using the Elympics SDK by reading about it in our documentation at docs.elympics.ai and by joining our community Discord. Links in the description below. Have a great day and thanks for watching!